Hello students, in this video we will study the different terms which we will be using in projectile motion. First term is time of flight. Time of flight. Time of flight is the time taken by the projectile to complete the whole motion. We already know that in projectile motion that we take a body, right, and project it at an angle, right? This is the y axis I have taken and I am taking an x axis, right? Yes, this is two-dimensional motion and motion in a plane, we can say. This is the x direction and this is the y direction. Okay, now this is the origin, and what we do, we take an object, a bullet or an object, we can take it, or shell or anything, or a ball, we kick a ball, let us say, and the body is traveling like this and falling like this. Fine. And yesterday we said that the shape is a parabola. Usually in mathematics when you study, you will say a shape like this, right? But here I have got it in this way, right? It is like this, and this shape is called parabola, and we proved that ax minus bx squared was one of the equations for the parabola. Fine. With that concept, now let us say the velocity with which I project is u, and the angle it subtends is angle theta, and from the origin the horizontal distance travelled is called range. So the next factor which we are going to talk about is range. Range is the horizontal distance covered by the projectile. Fine. Now also the projectile has a maximum height. It is traveling a maximum height, that is called h. This point P, let us suppose, right? It takes the path O, P, and it comes and strikes at the place point called PQ. OPQ represents a parabola. It represents a parabola. Okay, fine. Now what we are going to do today, we are going to define these three terms and then find an expression for that. First one today we will take is time of flight. Okay, we will call this as capital T, time of flight. Now what is the time of flight? We have to go do. Basically we are going to use the three equations of motion. Let me take the first equation of motion. What is that? V is equal to u plus at, but we are talking about here horizontal vertical motion. I can say u plus gt. Fine. Now watch carefully, these equations are not difficult, but only thing is you need to carefully make substitution so that you can get the correct result. Now watch here, the initial velocity u, I am going to resolve it into two components, right? Perpendicular components. This is x component, ux. What is ux? U cos theta. Right, and take another one component here. This is y component, uy. What is uy? That is u sin theta. We have done resolution of the initial velocity. Time of flight. How is the body going? It's going now upward direction. Upward direction. So when the body is at the maximum highest point, what will be its velocity, vertical velocity? That is 0. It is going to be momentarily at rest and then it is falling down. Till then it is going on moving up. It comes to momentary rest and again it is retracing and falling back the other side. Okay, so the final velocity at this point is 0, which is equal to u. What is the component responsible for this body to move up? That is the vertical velocity. That is the vertical velocity. So vertical velocity is uy or u sin theta. So I'll put it as the component is uy minus gt. Why I put minus gt? Minus because the body is moving upward direction. Okay, I will bring here 0 is equal to u sine theta minus gt, or bring gt this side, gt is equal to u sine theta, or t is equal to u sine theta. Now what is this t? U sine theta divided by g. Okay, now what is this actually t? It is the time taken for the projectile to move first half, OP. And what about PQ? They both are symmetrical. These both shapes are symmetrical. So the time taken to travel the first half and to fall back, it will be same. So the total time taken t is equal to 1 time t, that is small t, and 2 times t, which is equal to 2 u sine theta divided by g. So this is the formula for time of flight of a projectile. I hope you understand. We have taken the point P, the maximum point, the velocity is 0, and initially it is moving with a particular velocity, and that velocity is the vertical component. So I have substituted it, and I have taken first equation of motion, and I have derived the formula for the time of flight. So time of flight is the time taken by the projectile to travel the upmost part and then to fall back on the ground. That is called time of flight. So let me take here the formula 2u sine theta divided by g. So this is the first equation which I have done. Okay. Now we move on further. Fine. We will define now range. What is range? Range is horizontal distance traveled. Okay, we know velocity is equal to distance traveled by time, which implies distance is equal to velocity into time. Here velocity is range, distance is range, and what is velocity? Velocity here is the x component, because the projectile is able to move up because of the vertical component and able to move horizontally because of horizontal component. So I'll put ux, which is responsible, into time. The time of flight which is going to take is t. So what is vx? That is u cos theta, or velocity I use the symbol u. So ux is u cos theta multiplied by u cos theta multiplied by time of flight. For it to take the whole thing, that is 2u sine theta divided by g. Yes, u is there, that is u square, right? 2 sine theta into cos theta divided by g. Fine. Now you see, u I have taken the factors together. 2 sine theta cos theta I have put it in one group and divide by g. Mathematically, what is 2 sine theta cos theta? What is that? Actually, it is sine 2 theta, that is equal to u square sine 2 theta divided by g. This is the range of the projectile. Keep this in mind. Yeah, these are the basic derivations which you will be using in projectile. Even to do numericals, you need all these basic concepts. Time of flight, then you have horizontal range, and then last one is the maximum height displaced, right? So that is equal to r is equal to u square sine 2 theta divided by g. Okay, this is done. Now we will move on to the last concept, okay, that is maximum height reached. Let me remove this now. Now, which is the three equation which will be satisfying us for finding the maximum height reached? I would like to take the third equation of motion, which is v square minus u square is equal to 2gh. V square minus u square is equal to 2gh. Now, what is this? This is vertical motion. In vertical motion, as usual in the starting, what is the final velocity? 0. Then it falls down. Okay, the same thing, it is falling down. Okay, so final velocity is turned 0. So what I have here? Only the initial velocity. Initial velocity is needed because without the initial velocity the body will not go up. Because I am projecting with a particular value. The vertical component is only taking it a particular height. Okay, so the maximum height reached this component minus u square. This component is the y component, which is equal to 2gh. Okay, so let me start it from the equation. That will be much better for us. Okay, from third equation we have v square minus u square is equal to 2gh. And we said that this is 0 because at the maximum point its velocity is 0. So you have minus u square is equal to 2gh, or minus the x component we are talking about, x square is equal to minus 2gh. Why? G is negative, it is going upward. So I brought a negative sign here. So this negative sign and this negative sign gets cancelled. And what is the y component which is taking it up? Right? That is u sine theta. Okay, u sine theta, the whole square is equal to 2g, the height travelled h we will say. Okay, or we will say that u square sine square theta is equal to 2gh, or we can simply say h is equal to u square sine square theta divided by 2g, and this is the formula for maximum height travelled by a projectile. You can see here in all these equations very carefully. Yeah, let me erase all these parts now. Derivation we have done with third equation, fine, and I have substituted all the values and I got the result. Okay, now let me take the things and tell you exactly. This is the first one, right? We call this first equation. The second one is for range is equal to u square sine 2 theta divided by g. Let us call this equation number 2, right? This is the second definition, and third definition is maximum height reach is equal to u square sine square theta divided by 2g. Call this as the third equation. And let us watch carefully in all the three equations. Theta is angle of projection which is constant. You fix it 45 degree, 60 degree, 50 degree, any amount. Okay, and u, initial velocity, the velocity with which you are going to project, that is also fixed. Fine. And g is acceleration due to gravity at a particular place is going to be constant. So you see majority of the factors which you are having here are known values and they are constant. So it all depends on with what speed you project the body and what angle you throw the body. On these two factors you will find that the time of flight, the range and the maximum height reached will depend on. In the next video, we will do some numericals. The numericals will give you a better understanding of the concepts. Thank you.